Good morning again, everybody, and welcome to Astronomy 100. There is a question in the chat right now. I know it's directly the message to me, so since it benefits everybody, I'm going to answer it. That is because today is actually an extraordinary emergency, basically, thing that we're meeting today. Usually we meet on Tuesday to schedule the entire week and talk about the week and so on and so forth. Some of you will probably need to leave, which is fine. Or some of you are not actually right now in here because this is not the entire class right now I'm looking at. So you are still required to watch the recording. And I'm going to show you exactly where the recordings are being posted. Okay, obviously, they are actually first posted to YouTube. So if you subscribe to the YouTube channel, you get them at once immediately, and you will benefit from that expedited service. Now, they will be posted to YouTube. I'll have to fix some stuff with that, the video. Once it becomes available, then you can watch it in the class. Basically a session, which is usually every week has a live session discussion item. That is where they are going to go, okay? So you can still come later on, go to the live session discussion section of that week's module, and that is where you find the video if you happen to join us late, or if you happen to leave right in the middle for one reason or the other, or you did not watch the entirety of the video. You have to do that in that section, and I'm going to show you where these things are. The thing with it is, there is always an assignment based on those live discussions that you're going to answer it in there. So you really have to watch this one, okay? So let me share with you the screen. Before I share the screen, let me say something. You should have received a message from me this morning, okay? The message is concerning an assignment that is actually in this week, a homework assignment, okay? One of you guys, and it's not from this section, it's actually from another section, asked a question related to that assignment. Since I thought that this answer benefits everybody and not that student only, I made a video and I shared it with you guys to help you with that assignment. Basically, the assignment deals with the tilt of the axis of the Earth with respect to the ecliptic plane. So this is basically the Earth. This is the axis north. This is the south. This is the axis that penetrates north-south and goes all the way to the celestial sphere, all the way to the sky. And in the middle in here with this dark pen, with this black pen, I tried to draw the equator. In here, in between this one, this is a tropical region. It's the 23 degrees above and below the equator. That region is called the tropics. In the northern, in here, about 6 degrees above the equator, when you go in the equator, remember this is the latitude, 90 degrees is just here in this point. So around 66 degrees, you will find the next point, which is the Arctic zone. Okay, this region is the Arctic zone. There is another Arctic zone below. I did not draw it, but it's also there too. So the question was asking you, right now, if this is the ecliptic plane, this is the plane where the planets go around the sun, okay? The Earth is not sitting at this angle. It's actually tilted a little by 23 degrees. As it moves around the sun in this configuration, it's going to produce the seasons as we know them. The question was, what if this tilt is actually more like 50 degrees, twice as much? Because right now it's 23 degrees something, 23 degrees and a quarter. If we double that number, we put it at 50 degrees. What happened to the tropical zone and what happened to the Arctic zones and also the seasons on the planet? So because the Earth is a three-dimensional object, it's easier to visualize it with a three-dimensional object. Much easier than to do it with a two-dimensional object on a flat surface, like for example, on a piece of paper or on the screen. It's hard to imagine it, but it's much easier to model it. So what I tried to do in that video is basically try to represent this motion in two different angles, the current position and the hypothetical position. That was the question that he's asking. This question is important because right now we are trying to discover exoplanets, planets outside of the solar system, and we want to understand what's going on. Do they harbor life? Do they have life in them? Okay, so that is the questions we're trying to understand. And one of the things we know influences life extensively on Earth is the seasons, And the seasons are really due to the tilt of the axis of the Earth with respect to the ecliptic plane, the plane where all of the planets move around the sun. So how that is going to matter is very important. One of the things that we discovered lately are these planets outside of the solar system, which we call exoplanets. And those exoplanets, for the most part that we discovered them, they are very close from their host star. So in other words, they're close enough from it to be gravitationally tied with it so that they only have one face to the star all the time. In other words, the seasons there do not appear as the seasons on Earth in a year. The reason why that is, it's like the moon, for example. When you look at the moon, it's always one face facing the Earth only, because the Earth and the moon are tightly locked. So in a sense, the moon always faces the Earth in one side. Similarly, those exoplanets near their host stars, because the techniques that we have today are only powerful enough to discover this very near star objects, because when they are very near their star, they block the sun enough for us to be able for our systems that are sensitive enough just to that kind of level of stellar brightness. So when it dims a little, we can find the object that made it dim. However, when the objects are far, because it's not true that all of the planets outside of the solar system are very close from their stars. They range in all distances, but we cannot discover them at this point because we don't have sensitive enough equipment to find them, because planets, and like stars, do not emit light on their own. They reflect light. And that is why it's very hard for a bright object, the star it is, to outshine its neighborhood and to find the light from the other source, unless there is some sort of a stellar eclipse. If the star is hidden completely, then maybe we can find that planet next to it. And we did that technique. But the point being in here is this assignment helps us explore more ideas. Obviously, the assignment has nothing to do with the exoplanets and things like that, but it has to do only with the tilt of the axis of the Earth with respect to the ecliptic plane and what happens when that tilt doubles. So the purpose in here is to help you basically visualize that and answer the question to the best of your abilities. Obviously, you can work in teams, so we're going to talk about that one. Okay, so that was one thing. The other thing that happened also, and I already sent you a message before that, and that the meeting that happened yesterday at 1 p.m. I know I invited everybody, whether it's supposed to be for STEM and chemistry majors, but it's anybody actually was welcome to attend. And I was hoping that some of you would show up. And I really didn't take the attendance because there are so many people. But if you did not attend, it's not too late. So I'm hoping that you still are involved with this kind of activities, because it might stir your interest, and basically, who knows, maybe you would like STEM enough so that you can go into those fields. And also, if you are not already in there, so I'm not making the assumption that none of you is in there. Some of you probably are in there already. So that is one thing. There was so many interesting stuff that came out of that. One of them is a project by UCS, the graduate students, to collect, apparently I didn't know that the our region in here does not have a the air basically quality sensors that collect data. Apparently there is at least all kinds of data everywhere except in the region. So we needed that, at least part of a research project that the UCSD students are involved with, grad students. So they are hoping that to recruit some of us in here in the college to collect data and help them basically analyze the air there and come up with the studies to make the proper recommendations. Also, there was another also similar study by UC Davis also that they want also students, and actually they would pay the students to collect the data for them and send it on a regular basis. Also, that is something that is of interest, hopefully, to some of you. And actually, there are some companies that they're moving in the area and they're looking for technicians in the chemical fields to basically do all kinds of analysis and stuff like that. So who knows? Maybe you will change careers completely, not just not just majors, and become involved with this project. So there's all kinds of interesting things that are happening. There is something that I talked about in the past, and now we don't know the exact date for it, and that is the James Webb launch, which is part of the discovery of, among other things, exoplanets. There are other things that the James Webb is interested in. And I have had a chance actually to go about 2 weeks ago to it before it's being sent to South America, to French Guiana, to be launched from there. So I saw the whole thing basically with, of course, a group of other students from another college, where we saw the James Webb basically completed basically all of its assembly, and they are still testing and running all kinds of tests here in Long Beach in near Los Angeles. Anyway, the thing with it is, we don't know. It was initially planned to be on October 31st, its launch, but now they changed the date, probably in November, potentially around that time when it's going to be launched. So we don't have an exact date yet. I'm hoping that some of you also, and this is part of our class now, will join us in there to basically celebrate its launch. And hopefully we discover a new science that's going to impact, among other things, our subject. So, and there are other interesting stuff that we're hoping also to achieve in that. So that was for yesterday's meeting. So I'm hoping that some of you will get involved. And who knows, maybe you will have fun. Okay, maybe you will change majors and even careers out of it. So that is really the whole purpose of this, and it's open to everybody. So that is the things that I wanted to share with you up to this point. The first one dealt with the assignment, and the second one is with this item in here. And also another thing, so that you guys know, not yesterday, I'm sorry, Tuesday, I was on campus, and I was actually sent messages. I don't know if you guys received it or not, that I will be on campus, and if some of you want to meet, that's fine. Here's the deal. I'm planning, and I really did not have a firm date yet, but most likely it's going to be a Wednesday where I will be on campus on a regular basis. However, if you want to meet with me, please send me a message, send me an email at least a day ahead of time to schedule you so that we can meet there, and I will be there physically actually for you, where we can meet and sit down and talk about this one. I'm going to have only one person at a time in the office, so it's going to be on a limited basis. So if you are interested, shoot me an email and we can sit down and talk and basically go through the stuff that interests you. The thing with it is, you have to send the message ahead of time, and I will be there. This coming Wednesday, though, and it still can be happening on campus, I am planning because other sections, and probably you too also are interested in having a step-by-step process for that activity from week 2, the one that has to do with the stellarium. Remember, it's supposed to be an optional activity, and that optional activity was supposed to help you basically become more familiar with the stellarium. So I'm going to dedicate that time on Wednesday of next week, where we go through the stellarium activity step by step. And it's an open session, basically. If it takes an hour to finish it, we do it an hour. If it takes 2 hours to do it, we do it in 2 hours. But the point being in here is that at the end of the day, everybody who attends, this is not required, everybody who attends will hopefully come out of it with something that they will benefit from it. Look for a message from me either today or tomorrow concerning this one. So this is the stuff that is, obviously next week we're going to meet on a regular time, which is the time where we normally meet on Tuesday.
Is it okay if I could answer the prompt?
I know I said a lot.
If I could answer the prompt.
The prompt is still not assigned. Okay, I'm going to tell you what the prompt is.
Oh,
Are we going to be meeting in the planetarium?
No, we're not meeting in the planetarium, we're meeting online. We cannot do the planetarium yet because I think they have the technicians from the company that we bought it from are coming, first of all, to test it and make sure it's serviced first, because they want to make sure all the light bulbs are working and everything else, the software is working and everything is working for it. Okay. So we can't do that yet. That's a good question, Christian. We're doing it online. So we're going to say, what for more details from me, at least for the stellarium, not the planetarium. Sounds good? Yes, no, maybe?
But
Yes.
if I attend the live session, will it skip record?
We will on Wednesday, yes, I'm going to record the sessions, okay? All the sessions will be recorded, okay? Unless it's a private session. Unless it's a private session, in which case I don't record them unless the question we decide that might benefit everybody, in which case I will get the permission of the person we're having a private session to record that part, okay? For week 2, Carlos, it should be in the discussion in week 2. Okay, so let's start sharing the screen so that hopefully can help answer a lot of your questions much easier. Okay, share. And let me, where is the chat? Here is the chat. Put it in here so that they can see what the chat is. Okay, so you are looking at the models from the vantage point of a student. Now it became familiar. This is where the live session for the discussion for week 2 is. So it should be here. When I click on it, this recording, you're supposed to watch the entire recording. Okay. And once you watch it, you can find the prompts in there. I think there are 3 of them in there. So we really have to do to go through it in detail. This is, how long is this recording? It's about an hour and something. So you really have to go with a piece of paper. The reason why I'm doing that, it's very, very important that you really have to know what's going on in the class. You really have to watch this recording. So it's not good to just give you the points. Here is our questions from last week. Go ahead and answer them, because it really defeats the purpose that I'm hoping that you guys will come out of this, and that is to actually know what's going on. Because having the summary of the summary is not really good, because this entire thing is not supposed to be in lieu of. It's not supposed to be a replacement of anything. As a matter of fact, that's the assignment today. We're going to talk about exactly what needs to be done. Okay, so watch this please in detail, and if you still have any questions, please let me know. Okay, again, let's talk about week 3, because this is where in the middle of it and we need to understand what's going on. This is a summary of the week before. Okay, this is what you have been noticing, the summary of the week before. This is basically the plan, so that we know what we're doing. When we meet the first time around in the week, it's just to talk about a summary of what's going to happen in this week. Okay, then the next week we come back again, I come back again and give you the summary of that. It's really my take on those things. It's my version of it, if you wish. It's not a replacement for reading the units. There were 3 units last week, and there were 3 units the week before. So there were total.
But how many sentences can you write in a summary?
I'm sorry, how
many sentences can you write a summary for?
You don't have to write anything. This is my summary, okay? This is what I am saying in here. So when I do the review, it's my recording or videos to summarize the points we discussed the week before, okay? So you're not supposed to write a summary. You're not to do anything, okay? As far as this one, you are supposed to read the units 1 through 3 from the book. You are supposed to read units 4 through 6 from the book. And this week, you are supposed to read units 8 through 11 from the book. What you find out today is, I'm going to talk to you about these units, and I already provided you with the PowerPoints of these units, okay? That is not a replacement to reading those units. That is just to help guide you reading those units. So what we're going to do today, what I'm going to talk about today is basically my version or my summary of that. So I'm going to open those 4 units in PowerPoints, and I'm going to talk to you about them. So when you go and read them later on, what we do today helps you basically focus on those 4 units. So when you read them, you find out. The units are very short. This book calls them units, they don't call them chapters because they are more like sections of a chapter, not full chapters. And because the book is divided into several parts, each part has different units. We are still in part 1, and these are the units in it. So you're supposed to go through these units and read them. Attend the live session and watch it recorded to help you in your reading so that you know how you read them. Because 5 pages per unit times 4, it's about 20 pages, should not be a lot of reading. And by the way, even if we're doing a live class, if we're attending an in-person class, I will still require you to read it. Although I will go and do demos in the class, and we'll probably also write stuff on the board and things like, and I even give you handouts, but it's still, you are required to do the readings. The readings in all of my classes are required. So in a sense, in here, you're going through all of those 4 units and read them. And what we do today is to help you guide basically through your reading. So it becomes like landmarks. This is what he talked about. Oh, wow, this is what it is, but maybe he was wrong. Maybe I was wrong. So you can discover that. The point being in here is this, what we do today is not replacement to your reading, but it should help. That's the point. A week later, when the next unit is posted, unit 4 is posted, you will see a summary of these 4 units. Okay, again, it's my version of it. The item of the discussion today, okay, is that reading is essential. Okay, reading those units is essential. Do not skip the reading. I understand some of you don't have the textbooks, but try to get your hands on an electronic version if you can, or ask somebody, or try to get the book as is.
But what if you may read the units?
I'm sorry?
And do the reading. Is it okay to do the reading?
Yeah, you have to read the units, okay? So
mark all done if I read?
Yes, please, okay? But you have to do the reading. So reading and understanding.
So how long will it take?
Depends, basically, if you spend, if you go from the beginning to the end, depending on how, because you'll have to take notes and do the example, so it may take probably half an hour or something. But if you are a fast reader, it may take less than that, depending, okay? It may take longer if you are busy or doing some other things, or it may take an hour, 2 hours, depending on the time. So the time is not really, you should really dedicate time to this ones in here, okay? I would recommend an hour. I would still recommend an hour, even though you're dedicated in there, because you really want to go thoroughly and understand that part, okay? So here is basically the prompt. I posted it to everyone to look at it, so that you can copy it and paste it today. But this is just one, so we're still not done. So the point being in here is reading and understanding.
We're not finished yet then.
Yes, we're not. It's not necessarily that we're done with this one. So the point being in here is you have to read and understand what's going on, even though I summarize it, even though later on we come back later on and give you another summary of it. But that should serve as a guide, basically, as landmarks when you are reading, so that to help you with the reading. 4, 5 pages should not be hard to do, and per unit. Right now, it's going to be the probably one of the longest readings, but that should be manageable because it's essential. When test comes, when a quiz comes, when an exam comes, it's going to be based on what you read and understood, not based on the summary of these PowerPoints or what I told you so, okay? So based on what you do and what you understand from there. So that's why it's important. So if you want to do well in the class, this is what you have to do, okay? That's what you must do. So this is the item of the discussion up to this point. Make sense?
Yeah, it does.
Okay, very good. How about everybody else?
Yes.
Okay, very good. Okay. Okay, so let me talk about the last item in here from this week. It's a homework assignment. I already sent you a message concerning this homework assignment about one of the questions. And hopefully you can go through the other question. And again, you are supposed to work in teams, and you can consult the books. You can consult Google if you like. You can consult whatever you want to. Spend as much time as you need on the homework assignment. It is not timed.
But should I work on a team to do homework?
Everybody is actually encouraged, strongly encouraged, to work in a team of no
I
more
should be
than.
on team then.
Yes, you need to find somebody to work with, hopefully, and then start working on this assignments together. This is
I should do it together then.
Yes, you have to find somebody. If you can't, please let me know, and hopefully we can arrange for a group of people, okay? So the point being in here is this. This is not an exam. A homework assignment is.
What do you mean it's not an exam? Tell us.
Hold on, Ivan. Can I finish my point, please? Okay.
Sure. Continue.
Okay, thank you. Okay, here is the point. What we want to do is you learn what is in the assignment, okay? This is a homework assignment, so you need to know how to do these things. That's why you have as much time to take to do it, and you can work with other people or resources and finish it. That is the key in here, and you have to understand it. Now, if you have a question because you can do it or you don't understand the question, shoot me an email, shoot me a message, send me a message saying I have a question about this assignment. Like what happened with this student from another section who sent a message where he needed help with that question, and at the end what I did, since I thought the question merits everybody can benefit from it, so what I did, I recorded an answer and I posted it to everybody. So this is the plan, and if you are still in need more questions about it, I'll be more than happy to meet with you on a one-to-one basis and work with you on that, okay? So that we can move out of this point in here. There is another assignment in here, and that is a quiz. Now, this is a timed assignment. This is unlike the homework, okay? This is a timed assignment, and let me explain the process. I don't want you to basically be frustrated with this one. You should not. I think everything is self-consistent in a sense. Everything you need is in the class. So you have 3 attempts at this one, and the system will take your highest score. Some of us have difficulty sometimes taking exams, like quizzes, things like that. So since this is the first exam that we will have together, or the first quiz that we'll have, first of all, the chapters are covered, or the units that are covered from the first week, the first 3 units, okay? Now, for this quiz, you'll have 12 questions, 30 minutes to take them, 2.5 minutes per question. If, let's say, for example, I have 3 attempts, the first attempt, let's say, for example, I read the chapters and I think I know what's going on, so I open the quiz and I go through the entire quiz from question 1 to question 12. I do my best, and let's say, for example, I'm not happy with the score. Then in this case, I cannot right away start the next part. I really have to spend time reading those questions. The reason why I have to do that is because the next attempt, the questions are not the same. So I really have to make sure I understood what I am tested on. And I will tell you what you are tested on. So once you have that, then you're going to go back and take the next attempt. Now, if you are still not 100% liking the grade that you received, because it's going to take the highest grade, then you have a third attempt that you can still take, okay? Hopefully, between those 3, you're going to have the highest score that you can. A word of caution. Sometimes you will see this symbol. That is because Canvas sometimes does not allow me to write it this way. So this is what we mean by it. So what is tested in this quiz are the scientific notation. and it's part of the first 3 units. What is tested also in this quiz are the metric system. What I mean by metric system is meter for distance, kilogram for mass, and second for time. If they ask me, are these things written in the fundamental units in the metric system? If I don't see a meter and or a kilogram and or a second in some power of some sort. Let's say, for example, I have meter squared, second to the 3rd power, and I don't know, kilogram to the -3, for example, okay? So if I see it in this combination, it doesn't matter what is the concept, this is metric system, at least in terms of the fundamental units. If I don't see all of these 3 letters or some of them, that is not a metric system. Okay. And then, as I said before, is the scientific notation and the conversion and how to do basic operations with powers. That is actually discussed in there with examples from the first 3 units. Also, what is going to be tested on in this exam or in this quiz is the units used in astronomy. We don't use a distance in meters, although it's the metric system. We use the astronomical unit when we are talking in terms of the solar system. The astronomical unit is the distance from the Earth to the Sun. It's roughly about 150 million kilometers. That's the average distance between the Earth and the Sun. We take 150 million kilometers as the astronomical unit. So we say the Earth is 1 AU from the Sun. Jupiter is 1.5 AU from the Sun. Venus is 0.7 or 70%. The distance between the Earth and the Sun is the distance between the Sun and Venus, and so on and so forth. So as far as the solar system is concerned, we use the astronomical unit, which is the distance between the Earth and the Sun. When it comes to the stars, though, and even the galaxies, we use the light year. And the light year is a huge number. It's almost 10 billion kilometers. Because it doesn't make sense to use meters. It doesn't make sense to use kilometers. It doesn't even make sense to use astronomical units because the numbers become too big. So we use a light year. And we say Proxima Centauri, the nearest star, is about 4.2 light years. 4.2 is much easier than me saying 4 or 3 point something times 10 to the power 9 kilometers. It's ridiculous, okay? So we say light year, and a light year is almost 10 billion kilometers. Now, on a larger scale, though, we don't even use a light year. We use the parsec, and the parsec is slightly more than 3 light years in distance. Actually, it's 3.26 to be more specific. So those are some of the things that you should have discovered in the first 3 units. So the parsec is a much bigger, it's about 3.2. And we say in this case that Proxima Centauri, the nearest star, is slightly more than a parsec. So it's just more than a parsec from the Sun or from Earth, it doesn't matter. So that is basically some of the stuff you're going to be tested on in this quiz. Okay? So those are the units that you're supposed to be reading, and those are units that you're supposed to be tested on. If for some reason you have a question about this, or how am I going to proceed, or if sometimes you don't feel comfortable or you feel not at ease with quizzes, please let me know so that we can sit down on a one-to-one basis and basically work out all of those anxieties and see how we can basically overcome those, because quizzes are essential. It helps us basically focus on key concepts and take them. That's really why the quizzes are. And they are actually preparation for the exams that are coming down the road. So we don't want things to pile up at the end and then we'll be tested and then we have no idea what's going on. Make sense so far?
Yes.
Okay, very good. So those are the 2 things that we have going on right now. And then we have these 4 units. Again, I'm going to summarize what these 4 units are. You are still supposed to read these units of the book. So let me open them. Let me go to Unit 8 and stop sharing the screen with you and share with you that's Unit. Stop. And now share Unit 8. Okay. Let me put the chat session again in here just to make sure that I have that open. Okay. So the first unit has to deal with the lunar cycle. Okay, if you go outside into the night and monitor the moon at a given time. Let's say, for example, you promise every night at 11 p.m. I go outside and look for the moon. Where is the moon? Okay, and how it looks like. That is part of a project that is coming down the road, which is required everybody to do. So we're not going to be doing this in front of a computer all the time. So at some point we have to go outside and actually hunt for things and hunt for the moon, look for the moon, okay? If we can't find it, we can find it at night. Probably it's in the morning or in the evening before sunset, but that's another thing, okay? So we have to find it and find where it is and how it looks like. That is really how this one does. So it turns out that the moon changes shape and location throughout a cycle of almost 30 days, 29.5 to be more specific, okay? In 29.5 days, the moon seems to go at least through several shapes, from being nothing, which is a new moon, to a quarter moon, to a full moon, to a quarter in the opposite direction, back to nothing at all, and then the cycle repeats, almost 30 days, as I was saying. So we call this cycle a month because the word moon has in it, so it's basically the cycle of the moon, which is 1 month, okay? Now, the moon also, when it goes around, where is the, sometimes appears to be hidden from view, even when it's supposed to be visible, okay? Or sometimes actually the sun goes away in the middle of the day. So those are the lunar eclipses and the solar eclipses, but they happen only on specific times. They don't happen all the time. So since you're telling me that the lunar eclipse happens when the Earth hides the moon, and since the moon goes around the Earth all the time, at least once a month, so why don't I see this phenomenon at least once a month? Or you're telling me the sun is hidden by the moon when it's a solar eclipse, and since the moon is going around the Earth at least once a month, why don't I see that at least once a month? So that is the question. And the answer to that is because the plane where the Earth goes around the sun is not the same plane as the moon goes around the Earth, okay? The moon goes around the Earth in a plane that is not exactly the same plane. So this is where the moon goes around the Earth. And it makes an angle with the plane where the Earth goes around the moon. And that angle, the plane, by the way, is called the ecliptic. And that angle is the one that really determines when we're going to have that a solar eclipse or lunar eclipse. Example, the moon is in between the Earth and the sun in here, and we don't see a lunar eclipse, or we don't see a lunar eclipse, or we don't see a solar eclipse. The moon is not hiding the sun. The reason why is because its shadow, because it's above the ecliptic, is not falling on the Earth at all, and the sun is still visible, and the moon is still visible. On the other hand, this is a new moon probably when it's at the middle of the day. On the other hand, when it's on the other side, the shadow of the Earth does not fall on the moon because it's below the ecliptic. So in this case, I don't have a lunar eclipse. So the answer to that question is because these two planes are not on the same plane. They are actually tilted with respect to one another. Now, when these two planes cross each other, when they meet, that is when we're going to have either a solar eclipse, when the moon is between the Earth and the sun, or a lunar eclipse, when the moon is actually on the other side of the Earth and it's inside the shadow of the Earth. So in this case, I will have a lunar eclipse or a solar eclipse, and vice versa. When I'm in here also, I could have a solar eclipse or a lunar eclipse, depending on the position. So when these two planes cross each other, yes, I will have. That's why sometimes we will have lunar eclipses, solar eclipses, depending on where the moon is in its plane compared to where the Earth is on its plane. So that is hopefully answer some of this. So again, you're supposed to read this unit and hopefully understand it. And if you have any questions, please let me know. But this is just a summary of it, okay? So let me stop sharing that screen and find the next unit, which is unit 9, and share with you unit 9. And let me put the chat in here so that I have that open. And unit 9 has to do with the calendar. Again, we have different calendars that were used before. Remember, we noticed the Earth goes around. I mean, we noticed the sun, because at that time we didn't know that the Earth was going around the sun. That the sun completes a whole cycle in 360 some odd days, okay? And the moon completes its cycle in almost 30 days, okay? So we had to, since there is a 360 divided by 12, divided by 30 is 12, so we had to divide the year into 12 months. So we have the cycle of 12 months. So that is how we divided things. Furthermore, we noticed how the day is, because they repeat again. The day, morning, there is sun, evening, the sun goes out, morning, the sun comes in, day after. So we had to come up with a division on how many days there are in the week, basically. So we know about 7 objects that go around the Earth. At least around that time, we thought that they go around the Earth. We know about the sun going around the Earth, so we dedicated a whole day called after the sun, Sunday. Then we know also the moon goes around the Earth, and we dedicated a whole day to that. We called the day of the moon, or Monday. Okay. We knew also about Mars going around the Earth also. If you will follow it, that's another planet that seemed to move around the Earth. So we dedicated a whole day for it, and that's actually Tuesday. We know also about Mercury, that usually follows the sun in the sunset or precedes the sun in the sunrise. So that too, we gave it a name for Wednesday, so the day of Mercury, okay? We knew also about Jupiter, that also moves around the Earth a lot, and we had a day dedicated for Jupiter, which is actually Thursday. We knew about Venus also, that follows or precedes Mercury around its motion, and that we gave it the day of Friday, the day of Venus. And then finally, we knew about the day of, we knew about Saturn, so we gave it a day also, which is Saturday. So we knew about 7 objects, including the moon and the sun, so it divided the week into 7 days, okay? So that gives us a reference. So in a month, we still have slightly more than 4 weeks. So that's how we divided the calendar. Now, the trouble with this picture is we didn't know then about Uranus and Neptune, that they were discovered later. So if we knew about Uranus and Neptune, probably the week will have 9 days. So imagine a work week of 9 days. Wouldn't that be fun? You'll have more time to do your work. Yes, no, maybe. You guys enjoy 7 days better, or
Yeah.
9 days? Okay. No, that's all we knew. Okay, so we knew about 7 days. I mean, we dedicated 7 days for 7 objects. Okay, we didn't know about Uranus and Neptune, because if we knew, then we will have 9 days. That's basically the whole story. So that is how the calendar was invented. There was an issue with the calendar. We started with the lunar calendar. It's still used actually in some cultures, including the Islamic culture, where the lunar calendar is used extensively. But then we were using the solar calendar, which is fixed in the year. The lunar calendar moves from day to day. For example, this time, for example, a certain holiday happens in the summer. A few years down the road, it's going to happen in the spring, and so on and so forth, because of the fact that the moon does not exactly go in 30 days, and the fact that the sun is not 12 exactly times 30. So there is that off numbers, which also was true for the solar year too, which is a problem. That's why we have the leap years. The leap years have an extra day in them than the normal year. So that is because the numbers are not exactly matching. So that was one of the issues that we had to overcome. Other than that, these are the calendars. You will see down the road that even the Gregorian calendar has an issue with it. Things start to shift around big time because of the calculations that we use in the beginning were off by big numbers, and things like Christmas, for example, or Easter, they were happening not in where they're supposed to be. I mean, imagine having to celebrate Christmas in February. That would be wrong. So you had to fix these things. So let me go to Unit 9 first and find it. Unit 10, I'm sorry, we did 9. So let me stop sharing to make sure I am sharing with you this Unit 10. And let me pull the chat in here. And here it is. Okay. This is a fascinating unit. I really want you to go in depth and read about it, because an ancient time, in the Greek time and even around the Babylonian time, there were all kinds of measurements using trig functions, trigonometry, and based on that, we came up with an understanding on what shape is the Earth, and the answer was correct, a spherical shape, not a flat surface, okay? Number one. Number two, how big it is, namely its diameter or its radius or its circumference. It's the same thing, okay? The relationship between the circumference and the diameter is pi. And they knew about that a long time ago. Even from the Babylonian time, they knew about that. And also the ratio of the diameter to the radius is 2. Twice the radius is diameter. So as long as you know one of this, you know everything. So not only we knew that it was a spherical shape, but they know exactly how big it is. Then also they know also how big the moon is. Isn't this fascinating? They did not even have Google at that time or an iPhone. Yet they knew exactly the shape of the Earth, the radius of the Earth, and also how far the size of the moon, and how far the moon is, and how far the sun is. Let me explain how they did it, okay? First of all, the shape. They observed, and like what we're doing now, most of us are sitting in front on the couch, basically watching TV, and that's not how they did things at the time. They did not have that, so they were outside looking at things. If you observe during the lunar eclipse the shadow of the Earth on the moon, you will see that that shadow is more or less an arc, okay? An arc, indicating that the Earth at least is a circle, because the circle will give you an arc projection. But then another eclipse that happens several months later, it's still an arc. So if the Earth is moving and the moon is moving, so why in the world it's still always spherical in shape? I mean, a circle in shape. Because if it was a circle, at some point the projection of a circle will be a line. So here right now it's a circular, but if you project a circle on one of its edges, it becomes different. So since that difference was not noticed, the Earth then, that is casting a shadow on the moon, must be spherical. Not flat, spherical, sphere. And now we have people trying to convince us otherwise on YouTube. And these people are thousands of years ago, they knew about it, okay? Not only that. Let's say, for example, you are in the port in Greece, and you would want to go to Egypt. As the boat starts to leave in the sea, you will notice that the shore starts to drop in the horizon. And as you move closer to Egypt, to Alexandria, you will notice that Alexandria starts to rise from below the horizon until you reach it. It doesn't matter which direction you go. Even if you go to the east toward modern day Lebanon, you will see actually Lebanon starts to rise in the horizon. Or in the west toward Italy, you will see also that starts to rise in the horizon.
What
And
about
as
in
you
the
leave
south?
them, south is Egypt, okay?
In the
So
north.
whichever direction. North is when you go back to Greece, you will see it also rising in the horizon, from the horizon, or actually when you're leaving, it's dropping from the horizon. So the point being in here is we leave on at least the Earth must be spherical in shape, so that if this is true everywhere on the Earth, then the Earth must be a sphere. Because that is the only way, as you move away things start to drop from the horizon in every which direction you go. So that is how they knew that the Earth is actually spherical shape, not a flat surface. So they have at least two observations, the one for the lunar eclipses, and the second one is sailors. And at that time, almost everybody basically had to do that to survive. And even if you're traveling in the desert, you will see that phenomenon in the desert as the mountains start to rise as you're coming closer to them, or fall below the horizon as you're moving away from them. So this is how you can tell that the Earth is actually spherical at that time. And you didn't need the planes, you didn't need telescopes, you didn't need anything to discover that. Not only that, but in the time of the, in modern day Egypt, at least in a city called Sian, which is not too far from modern day Aswan, which is in southern Egypt, at some time in the year, if you put a stick, for example, on the ground, vertical, you will see that does not cast any shadow during the summer as the sun moves closer to the to that side. Okay. Now, if the on the same time, the same stick in modern day Alexandria, which was Alexandria at that time too, had a shadow, had an angle. The shadow makes an angle of 18 degrees. Based on the distance between Sian and Alexandria, you can extrapolate that angle of 18 degrees, giving you that distance and how big this entire circumference is. So they knew the distance, the entire circumference of the Earth. Of course, measured not in meters at that time. They did not have the metric system. They used the stadii, how many stadiums they are. So they know the size of the Earth in terms of circumference. So they know the radius. So they have everything. They know the diameter also, meaning the entire thing in here. So they have all kinds of things. They have numbers at that point. You have numbers. There is no question about it. Now, if you know that, and you know the projection of the Earth or the sun or the moon on the Earth when there is a lunar eclipse, how many projections there is on the Earth to produce the moon? They estimated the number to be about a third. So there is estimated then the size of the moon to be the third that of the Earth. So now you know the diameter of the Earth, the distance from edge to edge, but based on your estimates, you come up with a third for the diameter of the moon, which is very close from the correct number right now. So that means that also you have an estimate for the size of the moon. So you know how big the moon is based on your measurements for the Earth. Not only that, but you can tell how far the moon is. Let's say, for example, this is you, okay? And I'm going to put a quarter and a dime actually in here. So the entire view is blocked right now. Let me take this and put it as the moon. So you can't see the moon right now because I'm blocking it. As I move this one closer and closer and closer, you will notice that I have to stay in the same line of sight. As I bring it closer and closer, now actually the moon starts to appear from it. The moon starts to show. So I move back in here, I will block the entire moon and just the moon only. Using trig functions, which is a tangent angle, which is a ratio of the opposite to the side. And since you know the opposite, the size of the moon is, and since you know the size of the coin at that time, and since you know the distance of the coin to your eye, you can measure it with a ruler. Now you can find how far the moon is. 380,000 kilometers. Using simple geometry and little experiments, you can find how far the moon is. Not only that, but you can find also how far the sun is. So during a quarter moon, you can measure the angle for the sun when it's quarter moon. Based on that, and based on the knowledge of the distance now that you measured for the Earth to the moon, and based on that angle, again, using simple geometry, which is really the right angle triangle, you can find the distance to the sun. It's fascinating. Without any advanced telemetry or advanced radar technology or advanced anything, based on simple geometry and observations, daily observations, you can find all kinds of things. First of all, the shape of the Earth, the size of the Earth, the size of the moon, how far the moon is from Earth, and how far the sun is from the Earth. Isn't this fun? That's what this unit is all about. So hopefully you guys will read it, enjoy it. If you have any questions, please let me know.
I think I have a no comment then.
Okay, very good. Very good. So let me share with you the last one in here if I can find it. And that is planets and the model for the solar system, which is an important topic in here, Unit 11. And the chat session, which I'm going to pull in here. Okay. So again, we decided that, look, there are objects that move around a lot, planets, okay, in the sky, and objects that move, that are fixed in the sky. Those are the stars, okay? They are very far away, apparently, and we didn't know that there is a distinction between these stars and the other planets. Actually, a star is just a wanderer planet. A planet is just a wanderer star, that's all, okay? So once we basically have that, we tried to describe the motion of all of these objects, and we thought that they are moving around the Earth, and we put this Earth in the center of the solar system. One of the phenomena that was problematic for us was this apparent motion in the back of the sky of some objects, like especially Mars, okay? We called it the retrograde motion of Mars, because as you can clearly see in the night sky, all of the planets, everything, right, goes from the east to the west in a given pattern, okay? The pattern is well known, except that sometimes Mars appears to be moving backward against the background stars. Saturn also does that. All of the planets actually do that. So that was a problem, and we had to fix that. So in this model where the Earth is the center of the solar system, that's what you go outside and see. Everything moves around the Earth. So we call this one the geocentric model. In the geocentric model, we had to explain that apparent retrograde motion. So Ptolemy suggested the following, that the Earth, the planet is going in a circle around a circle where it's going around the Earth. So this can explain then retrograde motion, because at some point it seems like it's moving in the right direction. At some other times it's moving backward. And now you can explain how this apparent retrograde motion moving backward can be explained. But that's not good, because later on, Copernicus was asked actually to fix something in the calendar. As I was saying, the calendar was off, basically. Things started to move. Based on the Ptolemy model, the calendar 14 centuries later started to shift all over the place. So we have to fix that. And they asked him, actually was hired by the church to do that, to fix the calendar so that everything falls in the right place, okay? But in doing so, he came up to the conclusion that actually the Earth is not the center of the solar system, but the sun is. Furthermore, these things are moving in some sort of an onion shell. Some of these planets, like closer to the sun, are moving faster because they're closer, and the ones that are moving further away, they're moving slower, and so on and so forth. It's like a shell, an onion, basically, shells of an onion structure, and the sun sits in the middle of the heart of it. Then, in this case, you can explain also the retrograde motion based on his model. And in his model, you look from the Earth to Mars, and it appears to be in this projection on the night sky. You look at it later on, a week later or so, and it appears as the Earth is moving faster and it's overtaking it, it appears to have moved in the right direction. Later on, a week later or so, you're going to look at it and it appears to have moved backward. Instead of continuing in this line, it has appeared to move backward because the Earth is moving faster. If you look at it a little later, it appears to have moved even further in the sky. And then as the projection now starts to go straighten out, right in this line, it appears to have straightened itself, and now it's moving in the right direction again. And it's going to move in the right direction until it starts to overtake it. So now you can explain the retrograde motion using this heliocentric, meaning the sun is the center of the solar system. Obviously, that was a problem because we'll discuss that later on. One of his mistakes actually is that he made the assumption that the paths are actually circular paths, and they are not. Mr. Kepler later on came and corrected this one and came up with a better explanation for how this model is. Anyway, based on this geometry, based on this shell structure, we have the different positions of the different planets with respect to the Earth and the sun. and how they project. Okay, anything on the other side of the sun with respect to the Earth is called opposition. Anything on this side of the sun is called a conjunction. Furthermore, for the inner planets, for Venus and Mars, for Venus and Mercury, they have an inferior conjunction when they are between the Earth and the sun, and they have a superior conjunction where they are on the other side. Okay. Now, from the conjunction to the quadrature, based on this position of these objects, and based on an astronomical unit at that time, remember, he knew about how far the sun is from the Earth. We know that, okay, based on the previous unit. Then he was able to calculate how far these objects are, the different planets are, from the sun using simple geometry. He found instead of 0.39 astronomical units for Mercury, it turns his calculation gave him 0.38. That is very close from the correct answer. That is very, very close from the correct answer. Instead of 39 cents, you're supposed to get from the in change, the person told you, you know what, I only have 38 cents. Would that be okay with you? You probably are going to say, okay, what's a 1 penny is going to matter for you, for me? Okay, so that is basically how far off he was. Now, for Venus, he was right on the money. How much change you want? 72 cents, here it is. It was exactly where he needed to be. For the Earth, of course, this is just the starting point. We call it 1 unit. Basically, 3/4 of the way is Venus, and a little less than half the way is actually where Mercury is. About 1.5 times is where Mars is. And his calculation in modern day actual measurements, they match. Now, for Jupiter, he was off by 2 cents. But remember, from $5.20, you get $5.22. So we gave you an extra 2 pennies, okay? Which is not a problem compared to the big distance for Jupiter. So this is actually a very, very good approximation. Now, this one was off by quite few, but not that much. So if somebody tells you, how much is your change? You tell him $9.54. Looks at his drawer and says, only have $9.17. Would you forgive me? Probably you are, okay? If not, he's going to give you a note and come back later on for it, okay? The point being in here is that this number is not too far, albeit it's started to become off compared to the previous ones. But that tells you how much, also based on those observations and calculations, what we did, what we understood. Today, there was only that one item that I shared with you, okay, about the reading and understanding what you read. And of course, you have those assignments. Okay. Sounds good?
Sounds
Okay.
good.
Okay, very good. So I'm going to stop the recording.